Hey viewers, today I am going to show you the two-stage three-phase grid connected solar PV system. So at the early part we have seen the two-stage full system. Then we have seen this boost converter working individually. Let's in this part we will see the grid inverter, which is also known as the PWM rectifier. So in this part we will see the only the PWM rectifier function. Okay, so let's see the connections first. So you can connect the grid to the three-phase transformer. So the grid input is connected with the 230 volt, and the neutral is common for the all three-phase transformer, and 230 is connected with RYB, and output of this transformer 70 volt is connected with this grid inverter. Okay, so output of this transformer is connected here with the a dot, B dot, C dot and N dot point. Okay, and you can connect A dot, B dot, C dot to ABC point. Okay, let's see here ABC point. Okay, so it is connected voltage and the current in phase in the current, and voltage is parallel with the neutral. Okay, connected with neutral, and you can see the current A, B and C point is connected with the current input side. Okay, current sensor input side. The output of the current sensor is connected with this grid inductors. Okay, these three grid inductors are connected here, R, Y and B here. Okay, then the output of the grid inductor is connected at A, B and C dash, A dash, B dash, C dash. Okay, so here we have connected this current, voltage sensor, current sensor and the grid inductor, and A dash, B dash, C dash is directly connected at the IGBT's common point, A dash, B dash, C dash, and this is the inverter, three-phase inverter. Okay, so you can connect the DC negative rail here, EA, EB, EC. Also you can connect the C, CC, CB and CA. So you can make this three-phase inverter. Okay, then you can connect the EA to plus VDC, because this is working with the PWM rectifier. So here we have given the input voltage, and here we have get the DC voltage. Okay, so at this point you can connect this DC load, variable load. So as per your requirement you can vary the load and you can see the current. Okay, so here you can connect the load. So here we have connected the negative of the load, and CA is connected with this plus VDC. Okay, and here we have connected internally the IDC current sensor. So do not short this two connector. Okay, because it is internally shorted with internally connected the IDC current sensor. Okay, and the output of this current is connected with the positive of this load. Okay, then we have connected the DC voltage sensor parallelly at the load. So here you can see the connector is connected with plus VDC to sensor plus VDC, and the minus VDC connected with minus VDC, and also we have connected the capacitor at the output of this inverter. Okay, so we have connected the plus VC to plus VDC. Okay, and minus VC to minus VDC. So likewise this you can make this whole all connection for the PWM rectifier. Okay, and you can connect this controller. This controller is dedicated to the PWM rectifier. Okay, so you can connect the gate pulses GA to GC dash and 5 volt and ground with this connector. You can connect this at PA timer 8. Okay, and also you can connect the output of the sensor, current sensor and voltage sensor, and here is the DC sensor. Okay, we in the algorithm we have not used the IDC current, so here we have not connected. But if you want to change your code on code, and you can say, check this IDC current you want, then you can internally also connected this current, so you can use it and you can mention this pin. Okay, but whatever we have connected, the sensor output is connected at ADC. Okay, and here there's a switch. Okay, so by pressing this PD5 button, you can turn on the PWM rectifier and turn off the PWM rectifier. Okay, and here PD4 and PD6 is used for the VREF increment and decrement. Okay, and also you can see the PD3 and PD7 is used for the deck 1 and deck 2 increment. Okay, so here you can see the functions. Okay, and here you can see the deck values, different deck values. Okay, and you can see the connection diagram. Okay, so likewise this you can connect each and everything. Okay, here I will show you the sensor output values, and whatever pin you have connected at ADC, it is mentioned here. Okay, also we have written here whatever we have connected here. Okay, so likewise this you can make the connections. Okay, now let's turn on the system. Okay, so first of all the protection is here. Without you do not connect the grid, turn on the grid, then this protection will never goes. Okay, so once you can turn on the system, okay, you can see the display will update and you can see the system is off. EDC reference, IQ, ID, deck 1, deck 2 values. Okay, just wait. Yes, DC reference and DC actual and V phase voltage. So let's check. V phase voltage is here, DC link voltage. Okay, and here you can see the DC link voltage, and you can connect the load here, and also you can see the voltage and current graph. Okay, blue one is the voltage, yellow one is the current. Okay, now by pressing this button we will start the PWM rectifier. Okay, so you can see the display is updated. So IQ is 0, ID is 1.7 now, and VDC ref is and VDC actual is maintained 230. System is on V phase 70. Okay, so likewise this you can see the voltage and current is in phase. Okay, and here you can see the voltage is 230 volt and we have applied the 0.9 ampere current here. Okay, so now increase the load. Okay, so just decrease the load first, then you can see the voltage and current. Now increase the load. As you can see, it is try to maintain at unity when I am increasing or decreasing the load. You can see performance. Okay, so likewise this you can check the all three phase values here. Okay, and now let's check the current. So here the grid current is 6.8 ampere. .7 ampere, 6.7 ampere. So it is almost balanced current, three phase balance current. And this is this IQ is 0, ID is 9 ampere, deck 1, deck 2 values. Now we have also applied the protection here. Okay, it is once we have load the beyond the limit of the protection, then protection will active. So you can see the protection is active here, and here you can see the updated display. It is over current display. Okay, so at this time first you can turn off the grid. Okay, after that wait for the discharging the capacitor, then remove the load. minimum load you can set here, then reset the controller. Okay, then after you can turn on the grid and working perfectly. Okay, so likewise this, it is working with the PWM rectifier. And if you want to work with the same kit, it is working with the inverter also. Okay, so here you can connect the DC voltage. Okay, at that time you can connect this DC capacitor also. You can connect the DC voltage and current, and this is RYB, and here you can remove this inductor at that time. Okay, if you want to connect this inductor for the filter, then you can use it. Okay, but if you do not use, then you can directly connect this wire. This point, our inverter of output RYB is directly connected to this point. Okay, it is C star, B star and A star by using the short links. So you can connect the RYB current sensor and voltage sensor, and you can remove this transformer. So here directly you can connect the load. Okay, at this point you can directly connect the load, so you can get the output current, output voltage, and you can working with the three-phase inverter. Okay, and you can generate your own code for the three-phase inverter. So likewise this full system is working with the two-stage grid converter. Also individually it is working with the boost converter with MPPT mode. It is working with individually working with this PWM rectifier and also the three-phase inverter. So likewise this, it is working. Thank you.